Now we will be talking about how to create a graph of a quadratic function by finding the x-intercepts of a quadratic function by factoring, finding the y-intercept and the vertex. I know it sounds like a lot and there's a lot of new vocab, but we will get to that step by step as we will be looking at quadratic functions. So first, let's start from the quadratic. Let's take a quadratic function. Here's a simple quadratic function, ignore this for a second. We can see that it is a quadratic function, and our first task is to find x-intercepts by factoring. So an easy way to get to factoring a quadratic function is to draw a square, like I just did. This kind of square. In the bottom right corner of the square, we will put -6, our y-intercept, but we'll get to that later. Our top corner left, we will put an x, which is this, which is our x-intercept. Which is our x. And now it comes a little bit challenging. We need to find the factors of this function. So we need to think about the two numbers that add up to 6, which is this, that are multiples of 6, that are multiples of 6. So multiples of 6, but add up to 1. Because x is the same as 1x, right? Okay, let's brainstorm. What are multiples of 6? 6 and 1, 6 times 1, which is equals to 6. 2 times 3, which is equals to 6. Let's try 2 and 3. And would they add up to 1? Could be. Again. So now we are starting to look for the factors. So here it's x and x. So x, because this is going to be x squared. This is our x squared, -6. So if we will try to put -3 here, and we put a +2 here. -3 plus 2 adds up to 1. 2 times -3 adds up to -6. Do you see what I mean here? So let's put it in the square. So first we put -3x. Here we put 2x. 2x, -3 plus 2 equals to -1. So now let's put it in what we call factored form. So f of x equals x minus 3, x plus 2. And the way we can check it is by doing jumping the fence and doing it this way. So x times x, which is x squared, x times 2, which is positive, plus 2x. Now I do -3 times x, which is -3x, and then -3 times 2, which is -6. Now again, we simplify that, and we get, a +2 minus 3, which is -1x, and then we leave the 6. And it could be -1x is the same as -x minus 6. So, which was our initial function here. So there it is. This is our factor form. This is our standard form. Now let's move on. Since we got f of x equals x minus 3, x plus 2, now our goal is to find x-intercepts by factoring. An easy way, a way to find x-intercepts is by looking at the function, at the factored function. We can see that this is 3 and this is 2, negative 3 and positive 2. Our x-intercepts will be a positive 3 and a negative 2, 0. How do I know that? Well, there's a way for us to check it. If we do 0 equals x minus 3 and 0 equals x plus 2, we need to find x. So for this one, we do 0 plus 3, which is x3. For this, we do 0 minus 2, which is negative 2, equals x, which matches up to here. So those are our two x-intercepts. And now it is helpful for us in order for us to find the y-intercept. How are we going to do that? Well, let's see. As I initially said, in our function x squared minus x minus 6, in the standard form of a quadratic function, this is our y-intercept right here. So we could just say 0 minus negative 6. However, there is always a way to check it, and that's what we're going to do. We are going to plug in 0. So 0 minus 3, 0 plus 2 for our x. What do we get? 0 minus 3, negative 3, 0 plus 2, 2, negative 3 times 2, negative 6. So our y-intercept adds up to 0 and negative 6. Now, last part of finding our total quadratic parts for our graph is the vertex. What is a vertex? First of all, the vertex is the maximum or minimum point of a parabola, and let's try to find it. So it's either a maximum or a minimum point that when we have a graph here, there's this point right on top. This is what we call the vertex, or right at the bottom, which is this. So now, let's try to find a vertex. Since we know our x-intercepts, which are 3 and 0, and negative 2 and 0, our x-intercepts. We will start. The way for us to find the vertex is, which we need to do is add 3 at our x-intercepts and then divide them by 2. In that way, we will get, let's do it on a calculator to double check. 3 plus negative 2, which is 1. 1 divided by 2, which is 0.5. Interesting. We find our vertex, for the x-intercept for the x of our vertex, it's 0.5. But what about y? What about the y point? Well, we can also find that out now because we know that the value for x is 0.5, and what we do is plug in 0.5 in our quadratic factored or standard form. So as we do it, our initial standard form, which is 0.5 minus 3, 0.5 plus 2. So let's count that. 0.5 minus 3, which is negative 2.5. And 0.5 plus 2, which is our 2.5. So now multiply them both together, and we get negative 6.25. So that way we can find our y value. So vertex of this function is 0.5, 6.25. Negative 6.25. Okay. Now, what we're gonna do is graph it, which is our final step, and that's what we were wanting to do. So since our x-intercepts are 3 and negative 2, let's find 3 and negative 2 on the graph. So 3, 1, 2, 3, 3 is right here. Let me do it on the red, okay, which is here. And then our another x-intercept, which is negative 2, which is right here. Our vertex, okay, so here we have our x-intercepts. Now our y-intercept is 0 and negative 6. So we will be counting down 1, 2, 3, 4, 5, 6. So our y-intercept is right here. Now, our vertex, since we know that too. Vertex is a 0.5, which is right here on the graph, and negative 6.25. So negative 6, negative 6, negative 6, negative 6, which our vertex must be right about here. Okay. So what do we do now? Well, there's a couple of ways. It is very helpful to know about the line of symmetry. And that's the line that divides the parabola into two halves and is called the axis of symmetry or the line of symmetry. And for us to do it, we could just quickly draw it around here in order for us to see it better. So here, it's maybe not that clear on my video, but there's one point for that. So if it's one point here, then it means there's another point right there. So we will add that here. And now we can find more points on the graph by doing the same process by plugging in as we did for the vertex and for the y-intercept, but we can just very carefully graph our parabola, which is like going like this, and it comes and matches that and that, and it goes up, as we know. And here's our graph for our function f of x equals x squared minus x minus 6.